Okay, today we're going to look at linear relationships and nonlinear relationships. Does anyone know what a linear relationship looks like on a graph?
It goes in a straight line.
Yeah, it creates a straight line. So we have a whole bunch of coordinates here. And what we're going to do is kind of create our scatter plots and create lines of best fit. We're either going to decide that there is a linear relationship, so the line of best fit is linear, or the line of best fit maybe isn't linear, or maybe we can't even put one in. Okay? So we're going to create a graph each time. We're going to try to do this quickly. First off, shots and points. We don't know what this is really in reference to, but if we try to place it to maybe a sport, what do we think is the independent variable and which is the dependent? Yeah, most likely you need to take a shot in order to score a point, right? So this would be our independent, which means it's on which axis? That's right, x-axis. This makes this the dependent, which is on the y-axis. So our y and our x. We go to build this, okay? Our lowest number is 2, our highest one's 10. So we go 2, 4, 6, 8, 10. That works out great. And same idea, 2 and 8, 2, 4, 6, 8. Great, so we'll go by 2s. Okay, so here's our 0, 2, 4, 6, 8, 10, 12, 2, 4, 6. That's not 6. There you go. 8. Great. So let's plot these points. Now, this looks a little backwards. We're used to seeing usually x on the left and y on the right. So we have to be very careful when plotting these points. They're essentially reverse. Okay, so this is our x-coordinate, 2 and 2. Okay, so we have a point here, 2 and 2. And we'll use our dots for this. 3 and 4, so here's 3, this is 4. 8 and 10, 8. Oh, did I do that wrong? I did. See, even I get confused very quickly. This is our x-coordinate, so it's 4 and 3. 4 and 3 should be here. This is our x, so this is 10 and 8. Here's 10, 8, and 9, and 6. Okay, what type of relationship would you say this is? Do you think I could put a line of best fit kind of through this? Yeah, probably, but what would we like to have more of? Well, it's not always going to be as straight as possible. How much information do I have? Yeah, I only have 4. That's not a lot of information. If anything, who knows if the rest of it doesn't all end up way out here and these are outliers? Or maybe it's just going to end up all over the place and there really is no line of best fit. Okay, so though this looks like a good linear relationship, I would say there's not enough information here. Okay, this isn't enough information to really make a determinant of whether it's linear or nonlinear. Okay, next one. Height and weight. Which do you think is the independent, which is the dependent? We don't know what really in reference to. Height is what? Okay, our height is our independent and our weight is our dependent. That's probably pretty logical. I guess you could argue it the other way, but this probably makes good sense here. So these are our x-coordinates, our lowest one being 2, our highest one being 80. So we probably go by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, good. That'll work for our x if we go by 10s. Okay, so our x-coordinates are going to go by 10s. And everybody look at the other one. And by the time I finish this, give me an idea that will work. 3s. What's the highest we go? 10, and the lowest is 1. So if we go 3, 6, 9, 12. What if we go 2, 4, 6, 8, 10? That works even better if we go by 2s. So let's go by 2s. Oh, beautiful. Okay, let's plot our coordinates and see if we can't figure something out. 13, 5. So we're going to have to do a lot of estimating. Here's 13. Here's the number 5. 80 and the number 4. 75 and the number 10. It's way up here. Okay. Oh, sorry. Thanks, guys. 40 and 8. 60 and 1. Here's 60. Here's 1. 9 and 9. 9 would be here, and 9 is way up here. 20 and 6. Here's 20. Here's 6. And 2 and 1. 2 and 1. Do we have a linear relationship here? No. Do we have any relationship? No, this seems very all over the place. So this would be non-linear. Okay? We don't know what it is, but we would definitely call it non-linear, this relationship. This one, we're going to just say not enough info. Okay? Not enough info. Yeah, Anthony? Okay, next one deals with speed and braking. Probably maybe for a car. What do you think is our independent, which is our dependent? Speed is what? Okay, it's our independent, and braking is our dependent. Great, let's take a look. This goes from 10 to 80, so probably going up by 10s would be a nice number again on our x-axis. Okay, and while I'm doing that, if you guys can come up with a good idea for the y-axis.
5.
What do you guys think?
5.
Going up by 5s? Okay. What does it go up to? 40? So let's go 5, 10, 15, 20, 25, 30, 35. Okay, we'll squeeze in 40 at the last one. 5 is probably a decent number. Okay? And then we'll call that 40. Okay, so let's put our values here. X-axis is 10, y-axis is 5. Then 20 and 10, 30, 15, 40, 20. And it seems to be going up. Yeah, it's definitely positive. What kind of relationship would you call this? Yeah, this one's very obviously linear. Nothing was off. And even, let's say we had a point like here, maybe here, 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 here. Would you still call this linear?
Yes.
Yeah, I still would call that linear. That definitely looks like a linear relationship, okay? We'll take that away because that'll confuse you on your notes. Okay, and finally our last one here. They didn't give us anything. They just told us x and y, so we're going to take their word for it, that this will be our x-axis. Okay, so this is our independent, and this is our dependent variable. And it looks like it goes up from 1 to 7, so probably counting by 1 would be more than sufficient. So let's count our x's, and in the meantime, you guys can think of another one. Going up by 7. Let's see how many we have. 1, 2, 3, 4, 6. We have 7. Yeah, if you're right, we could go up by 7s in this case. If we were to go up by 7s, that would give us, what if we went 10? 10, 20, 50. 7's a good one. You guys think we can go up by 7s? You guys know how to count that way?
Yeah.
All right, let's try it. 0.
14, 21, 35.
Good. Okay. Let's plot our points here. First one is 0 and 0. The next one is 1 and 1. I would maybe put that there. 2 and 4. Maybe about there. 3 and 9. 4 and 16. These are all roughly estimates. 5 and 25. 6 and 36. 7 and 49. That's not even on our chart here. I'll say it's maybe up here. What type of relationship would you call this? Is this linear? I'm getting the feeling that this is starting to take off upwards. Okay? So I would call this a non-linear relationship. Okay? So this is non-linear. And the one before it was, yeah, it was linear. Excellent. Good job, guys. Okay, so we went over lines of best fit and linear and non-linear relationships.